Hello everybody, this is Mr. Shaban, and today we're going to have one of the chemistry lessons for year 9 syllabus. As you have taken earlier, we have finished the biology, and right now we're going to start with the unit of material properties. The first lesson is called the structure of atom. The structure of atom is 4.1, lesson 4.1. In today's lesson, we're going to have 4 lesson objectives. By the end of the lesson, you should know that atoms are made up of protons, neutrons, and electrons. The nucleus of an atom is made up of protons and neutrons, and electrons move around the nucleus of an atom. The last lesson objective is scientists from around the world have helped us understanding the structure of the atom. We're going to go through how the scientists have developed or discovered the structure of an atom. The keywords for today's lessons are atoms, protons, neutrons, nucleus, charge, along with electrons. So let's first talk about the structure of the atom. The structure of the atom consists of a core. This core is called nucleus. The core consists of neutron, which is yellow, represented in yellow color, and proton, which is represented in blue color. Surrounding the nucleus, we have levels or energy levels. These energy levels contain a red particle, which is called electron. So we can say that we have a core. This core consists of 2 particles, proton and neutron. And surrounding the core or the nucleus, we have energy levels where electrons are moving around the nucleus. The word atom came from a Greek word which means cannot be split. So it's the smallest unit which cannot be split. So as we have taken earlier that we have 3 different kinds of particles inside the atom. We have the proton, we have the neutron, and we have the electrons. Protons and neutrons both are found close together at the center of the atom in a place called nucleus. And electrons are moving around the nucleus. If you want to compare the 3 particles in terms of the mass and charge, here is the table which is summarizing that for us. This is the mass, and proton has 1, value of 1, neutron has a value of 1, and electron has no value. This means that the proton and neutron are having a value, are making the mass of an atom, while the electron can be neglected. It's very, very, very light, where it can be neglected from the mass calculation. On the other hand, when it comes to the charge, the proton has a positive charge, neutron has no charge or uncharged particle, and electron has a negative charge. So when you compare between the 3 particles, we can say that the mass of the proton is 1, neutron 1, or we can say that the 2 particles which are contributing or building up the mass of an atom are the proton along with neutron. While electron can be neglected because it has a very, very small value. So when it comes to the charge, proton, it's positive, neutron no charge, and electron takes a negative charge. Okay, let's see the history of developing or discovering the atom. The first scientist that has contributed in the discovery of the atom is called Sir Joseph John Thomson. This is an English physicist. This guy was studying physics, and basically his discovery was mainly built on the cathode ray. He has observed when he has emitted a cathode ray across an atom, he has found that the cathode ray, which is made up of a negative charge, was attracted to the positive charge and repelled with a negative charge. So he has estimated that we have a positive and a negative charge. He concluded that the rays consist of a stream of small negatively charged particles that have a mass less than 1000 that of a hydrogen atom. So basically the discovery of Thomson, he was the one that has discovered the electron, because he has found that the cathode ray got repelled with the negative charge. That's why it got deflected when it comes across electrons. So Thomson has discovered the electron. From this point onward, it becomes increasingly clear that atoms are not fundamental particles, but it consists of smaller particles, and this was one of the reasons why he has taken the Nobel Prize in Physics. And this picture demonstrates the Thomson atomic model. He said we have like a positive sphere, and this positive sphere consists of or contain negative charged particle, and we can take it like take the watermelon as an example, where the red part consists or representing the positive sphere, the positive charge, and the seeds are representing the negative charge. So his module of the atom, he said that we have positive sphere, and this sphere consists or contain negative charged particle. Rutherford, the second scientist, was a New Zealand scientist. He was born in Nelson, New Zealand. He is also a scientist in physics. Rutherford, along with two other students, his students, Giger and Mercedes, these have conducted an experiment which has contributed a lot in the discovery of atom. They have taken a beam, and they have fired the beam across a golden foil. So the alpha particles went through the golden foil, and I want to show you a diagram. Yes, here. See, he has the alpha particle source. He fired the alpha particle source across a golden foil, a very, very thin golden foil. They have found that most of the alpha particles, they went through the golden foil to the other side. So the green part is like a sensor that can detect the alpha particle. He has found that most of the alpha particle that was fired by the source went through the golden foil and then was received on the sensor over here. But also he has found that we have very, very few particles that got deflected. Deflected means they are not reflected, but they got a different pathway. They went through the golden foil, but instead of being collected over here, they went either to the right or to the left. And then we have a very, very tiny particles, like very, very tiny ratio, that got reflected back on the sensor. They have concluded that if a foil or like this layer of foil, golden foil, consists of one atom thickness, they have found that the alpha particle have found nothing to block its way. So most of the atom is space. That's why the alpha particles went through the golden foil. But we have small particles are found inside the atom, and when the alpha particle, which is positive, came across like nearby the nucleus, they make the alpha particle deflect. That's why we have these two rays. So these two rays came as a result of deflecting the alpha particles, as a result of having two charged particles close together. And when the alpha particle hit the nucleus directly at the middle, the alpha particle got reflected back and didn't go through the golden foil. So the Rutherford experiment can state three things. The first one, that most of the atom is empty. That's why we have most of the alpha particles went through the golden foil to be accepted or received at the sensor at the back. And we have a core which is found inside the atom. This core has a positive charged particle. When alpha particle came across the core, like nearby the core, they have repelled with each other to make deflection. And when the alpha particle hit the core, exactly the core, it was reflected back. So that was the conclusion of the Rutherford experiment. The second lesson of today is talking more about the structure of the atom. Mainly we're going to look at the structure of the atom. That's your second lesson of the unit. And this lesson has 3 lesson objectives. The first one, by the end of the lesson, you need to know that the atomic number tells you how many protons in the atom. The mass number tells you how many protons plus neutrons are there in the nucleus. Electrons are arranged in energy levels or shells. A shell must be filled before starting on the next one. The keywords of today's lessons are atomic number, mass number, positive charge, and negative charge. Let's start first with the periodic table. I want to have a small discussion with you based on the periodic table. Periodic table is a table that was originally made for the scientists to rearrange the elements which are found in nature in a certain way. They have arranged the elements based on their atomic number. This number, the smallest number. Over here, hydrogen has 2 numbers, 1, 1. Okay? So it's an exception. In any other element apart from hydrogen, you need to find a large number and a small number. Like as an example, helium, it has 2 and 4. So 2 is the smallest one. Okay, so we have rearranged the element based on the atomic number or based on this small number. So helium 2, we have lithium 3, beryllium 4, boron 5, carbon 6, and so on. So the periodic table is used to put the elements in order based on the atomic number and based on their properties. In year 9, you're going to study the first 20 elements. So we're going to study from hydrogen up to calcium. When you go for the IGCSE, you're going to take the other parts of the periodic table and you're going to know the pattern in the periodic table as well. So let's start first with the different sorts of atoms. The atom of elements increases in mass as you progress from left to right. I want to bring it back. As you can see, that's the atomic number as we have discussed, and the large number should be called mass number. So hydrogen has 1 mass number, helium has 4, lithium has 7, beryllium has 9, boron has 10. So as you go from left to right, the mass increase of the element. As you go from up to down, the mass also increases for the element. So each element has 2 numbers. The first one is called atomic number, and atomic number tells you the number of protons found inside the nucleus, and the atomic number gives you an idea about the number of electrons found outside the nucleus. So the atomic number is representing the number of proton along with the number of electrons. Both should be equal. So if we have over here lithium has 3 and has 7. We said the atomic number is always the smallest number. So the atomic number for the lithium is 3. This means that the lithium has 3 protons inside the nucleus and it has 3 electrons also outside the nucleus. But the number of protons should be equal to the number of electrons in a neutral atom. Let's talk about neon. Neon has 10 and has 20. Which one is representing the atomic number? Perfect. The smaller number represents the atomic number. So the atomic number over here, the 10, are representing the number of proton, number of electron. So both are 10. The 10 proton, it has 10 electron. For the argon, we have 18, we have 40. Which one is the atomic number? The atomic number goes for 18, exactly. So we can say that argon has 18 proton and it has 18 electron. Let's talk about phosphorus. Phosphorus has 15 and has 31. Which one is the atomic number? We go for the smallest. So 15 is the atomic number. This means that phosphorus has 15 proton and it has 15 electrons. And the mass number represents both the number of protons and neutron. When you add the proton and the neutron, it gives you the mass number. I want you to remember something. Mass number represents the mass of the element. Do you remember this table? We said that proton has a value of 1. Neutron has a value of 1, while the electron has no value, can be neglected. So mass, when you are measuring the mass of an element, We are measuring the number of protons and neutrons found inside an element. So the mass number, again the mass number over here, is representing both the number of proton and neutron. When you add the proton to the neutron, you're going to get the mass number. Proton is a positive charged particle, electron is a negative charged particle, and atoms has an overall no charged particle, because the number of proton, the positive particles, are equal to the number of electron, which are negative charged particle. So the overall charge of an atom is 0. It's uncharged particle because it has the same number of positive charged particle, which is the proton, to the negative charged particle, which is the electron. Perfect. Let's see some examples based on that. Lithium, it has 3 and 7. I want you to figure out the atomic number, mass number, and number of proton, neutron, and electron. So we said earlier that the atomic number is going to be the smallest number. So atomic number would be 3, and mass number is going to be 7. Then number of proton is the same as the atomic number, 3 as well. Number of electron, 3, same. Number of proton should be equal to number of electron, should be equal to the atomic number. So 3 of them in a neutral atom should have the same values. And then number of neutron, in order to calculate the number of neutron, you're going to get the largest number, which is the mass number, and then minus the atomic number. So we're going to have 7 minus 3 is going to give you 4. So the mass number or number of neutron is going to be the mass number minus the atomic number, which is going to be 7 minus 3, and it's going to give you a value of 4. So we have 3 protons inside the nucleus, 3 electrons outside the nucleus, and we have 4 neutrons inside the nucleus. We have another example for you. This is sodium 1123. So as we have discussed earlier, we have two numbers. The smallest number represent the atomic number. So the smallest number is perfect 11. That's the atomic number. And the largest number is 23. That's the mass number. In order to figure out the number of proton, electron, we need to get the atomic number. So number of proton is 11, exactly as the atomic number. Number of electron is 11, exactly as the number of proton and atomic number. And the number of neutron, you're going to get 23 minus 11 is going to give you 12 neutron. Perfect. Next example, we have aluminum 1327. I'm going to give you an opportunity where you're going to figure out the atomic number, mass number, number of proton, neutron, and electron. We have 13 and we have 27. So we have a smaller number and we have a larger number. We said smaller number represent something and larger number represent another thing, right? Yes. So let's double check the answer. Atomic number is 13, mass number is 27. In order to find out the number of proton, we said we get the value of the atomic number, it's 13 as well. Number of electron, the same as number of proton, 13. And we have the number of neutron, we're going to get 27 minus 13 is going to give you 14 neutron. Let's check another example, calcium 2040. So let's discuss, we have atomic number which is 20. The mass number is going to be 40. In order to figure out the number of proton, electron, neutron, yes, remember that fact, don't forget it. The number of proton, number of electron, both are going to be equal to the atomic number. So the atomic number is the smallest number, which is 20. So number of protons is going to be 20. Number of electrons is going to be 20 as well. And the number of neutron is going to be 40 minus 20 and is going to give you a 20 neutron. Another example, silicon 1428. Without reminding you, you have two numbers. So please go for it. Try to figure out the answers and then we're going to double check the answers together. Okay, let's start. So we have small number and large number. We said smaller number is always representing the atomic number and the larger number is representing the mass number. We said the number of proton is equal to the atomic number, perfect. So it's 14. Number of electron is equal to the atomic number as well, so it's 14 as well. And the number of neutron is going to be 28 minus 14, so we're going to have 14 as well. Another example, we have P, phosphorus 1531, atomic number is the smaller one, 15, followed by the mass number is the larger one, 31. And then number of protons is going to be 15, number of electrons is going to be 15, and number of neutrons is going to be 31 minus 15 to give you a value of 16. Perfect. Another example, hydrogen. Hydrogen has a small exception because hydrogen has an atomic number which is the same as the mass number. So I'm going to show you the exception right now. We have the atomic number 1 and we have the mass number 1. Number of proton is the value of the atomic number, so it's 1. Number of electron, the value of the atomic number, so it's 1. Here is the exception. Number of neutron, when you subtract the mass number from the atomic number, you're going to have 0. So basically, we have no neutron in the hydrogen atom. The hydrogen is the only exception where it has no neutron inside its molecule. So we can say that it has only proton and electron, while no neutron are found inside the hydrogen neutral atom. Magnesium is 1224, so the smallest number is going to be the 12 atomic number, and then followed by the mass number 24, and then the number of proton is 12, number of electrons 12, and number of neutron is going to be 24 minus 12 to give you a value of 12. Perfect. Okay, then we're going to talk about arranging the electrons. Arranging the electrons is how we can put the electrons around the nucleus. We have a certain way, a certain rule in which we need to follow in order to rearrange the electron in an atom. See, we said electrons are found in energy levels which is surrounding the nucleus. Perfect. We have up to 8 energy levels, but we're not going to go through them. We're going to take only the first 3 up to 4 energy levels. The first energy level take maximum 2 electrons. So if we're talking about a hydrogen, it has 1 electron, is going to be placed over here. If we're talking about helium, which has 2 electrons, we're going to place them over here. Once we have more than 2 electrons, then the third electron needs to take place in the next energy level. So we don't put electrons in the next energy level unless we reach to the maximum number of electrons in the current energy level. Lithium has 3 electrons. So the lithium, in order to put the electrons around the nucleus, we're going to put the first 2 electrons in the first energy level. The second and third energy levels takes up to 8 electrons. So in the lithium case, we have placed the first 2 electrons in the first energy level, and we're going to have 1 more electron because they are 3, and the third one is going to be placed in the second energy level. So you need to keep this in mind, guys. First energy level takes up to 2 electrons, second energy level and third energy level, they take up to 8 electrons. Here is beryllium, boron, and carbon. As you can see, beryllium has 4 electrons. We have filled the first energy level first with 2 electrons, and then the other 2 we have placed them in the second energy level. Second energy level can take up to 8 electrons. So we can, if we have like, as an example, argon or neon. Neon has 10, so we place over here 2, and around it should be 8. Boron, it has first energy level 2 electrons, and then the rest electrons will be arranged in the last second energy level. Carbon has 6 electrons, so we place the first 2 in the first energy level, and we put the other 4 around in the second energy level. Okay, guys, right now we're going to talk about the trends in group 1. Trends in group 1, this lesson has 3 learning objectives. The first one is the elements in group 1 share some properties. The trends in group 1 is that melting point and boiling point decreases as you go down the group, and the element in group 1 react more vigorously with water as you go down the group. And the keywords of today's lesson are alkali metals. So I want to share with you something. We said the periodic table is a table which has arranged the element based on their masses and based on their atomic number. So I want you to see that's the full periodic table. That's what you're going to take in year 10 and 11. So the periodic table consists of something called groups, which is going from up to down, and other things which is like that from left to right. This is called row or period. Okay, that's called period. The period is when you move from left to right, and the group is when you move from up to down. Let's recheck the learning objective one more time. So here we're going to take the trends in group 1. The trends in group 1. So here we have the first group number 1. Okay. Then we have group 2. Then we have group, that's 1, that's 2, that's 3, 4, 5, 6, 7, and 8. We're going to overlook these electrons, these elements, we're going to overlook them, and you're going to know that later. These are called transition metals, and transition metals have different properties than these metals. We're going to discuss that in details within the IGs, but for the time being, I want you to know that we're going to take the trends in group 1. We have 8 groups in the periodic table: 1, 2, 3, 4, 5, 6, 7, and 8. Okay, let's start our lesson. That's group 1 element. We're starting with lithium, followed by sodium and potassium. Okay, so as you go down the group, you can see that the atom size is increasing. I want you to see, we have over here in the lithium, we have, that's the first metal in group 1. We have 2 energy levels. In sodium, we have 3 energy levels. In potassium, we have 4 energy levels. Good. But you're going to notice as well that all of them, they are ending up with 1 electron in the last energy level. So lithium has 1 electron in the last energy level. Sodium has 1 electron in the last energy level. And potassium has 1 electron in the last energy level. Good. I want you to have a look over here. So that's the lithium. Okay. Hydrogen is a non-metal, so we're not going to discuss it. We're starting with the lithium because it's the first metal in group 1. So that's the lithium. As you go down, the size of the atom increases. But still, all of them are ending with 1 electron in the last energy level. So as you go down, the atomic number and the mass number both increases of the group 1. And as you go down, the melting point and the boiling point decreases. So not only that the atomic number and mass number increases, but also the melting point and boiling point decreases. So here is the highest melting point and boiling point, and as you go down, it decreases. Okay, I hope you have enjoyed today's lesson. In today's lesson, we have discussed lots of things. We have discussed the atom. We have discussed the history of discovering the atom. We have discussed how the atoms are arranged and the particles found inside the atom, how the proton, neutron, and electrons are found inside the atom. We have taken as well how to rearrange the electrons around the nucleus. We have taken the trend in group 1. I hope you have enjoyed today's lesson, and see you next time.